Hi, and a very good day. I bid to Dr. Mohammad Shazaruddin bin Marcet and everyone. Before going further, I would like to introduce myself. I'm Matesharon Alaki Gunarayu, matrix number 195980.
I'm Hui matrix number 198876.
My name is Atoga and my matrix number is 200072.
We are from Group 5 Wednesday session. We are going to present about Experiment 8 Marcet boiler. First of all, I would like to present the abstract. The experiment was carried out to determine the relationship between pressure and temperature of saturated steam in equilibrium and to demonstrate the vapor pressure curve as well. The Marcet boiler was used to determine the change of temperature of the water vapor system at different pressures. The temperature was measured at every 1 bar pressure intervals until the pressure indicate 10 bar. Then the system is cooled down by switching off the electric heater. The cooling temperature was recorded at the every 1 bar pressure intervals until it reached 1 bar. Hence, the relationship of pressure and temperature is directly proportional. For the next part, introduction, thermodynamics study about the interchange of heat and work between a system and the surroundings which occurs then when the system undergoes a process. Marcet boiler is a benchtop unit designed for the demonstration of the basic principle of boiling phenomenon to study the relationship between the pressure and temperature of saturated steam in equilibrium with water. This experiment was also conducted to demonstrate the vapor pressure curve. Water was boiled and every changes of pressure of 1 bar, the temperature was recorded until 10 bar. The theoretical background. The use of Marcet boiler is to investigate the relationship between a saturated pressure and the temperature of water from 0 to 10 bar. An ideal gas obeys the equation of state that relates the pressure, specific volume or density and absolute temperature with mass of molecule of the gas constant R, which is the formula is PV equals to nRT, where P stands for absolute pressure, V stands for volume, N stands for amount of substance, in simple word moles, R is the ideal gas constant and T is the absolute temperature, which is K. The measured value of the slope of a graph dt over dp saturated can be obtained from the data of result from the experiment done and compare it with responding values calculated from the steam tables. And here the Clapeyron states dt over dp saturated equals to VGF over HFG equals to TVG over HFG, which is we use to calculate the heat of vaporization of water. For the next part, the objective of this experiment is to determine the saturation pressure curve at the pressure within 10 bar, and it was carried out to investigate relationship between the pressure and temperature of saturated steam equilibrium with water, and also to calculate the heat of vaporization of water. For the next part, Hui will explain about the procedures and so on.
So the procedure for startup. First, the boiler was set up for heating and cooling process. So we have to make sure that there is sufficient water inside the Marcet boiler and the safety valve must be open. So for the experiment, first the Marcet boiler was turned on and then the steam was allowed to come out from the valve and then the valve was closed. This is done to purge the trapped air inside the boiler. So the steam temperature and pressure was recorded at intervals of 1 bar until the steam pressure reached 10 bar. So then the heater was turned off and the steam temperature and pressure began to drop. The steam temperature was recorded at intervals of 1 bar until the steam pressure reached the atmospheric pressure. So the equipment and component used. So this is the Marcet boiler and they have 8 components in the Marcet boiler. First is the safety valve, and then second is the boiler with insulating jacket. Third, we have the Bourdon tube, pressure gauge, and then we have the switch box, drain valve, heater, overflow, and the temperature sensor. So the instrument used, this is the instrument that we use that day, the Marcet boiler. So for the table, first we have to do the table, the steam pressure and temperature for heating and cooling process. It's all the data that we collected using the Marcet boiler. So then we have to do the table, we log the temperature and then the pressure and also 1 over T of the temperature and lawn pressure data. So table 3 will be the experiment data versus the steam table data value. So this is the graph that we plot using the Excel. So the first graph will be the graph of absolute pressure against temperature, and we use the experimental data together with the theoretical value. The theoretical will be obtained using the steam table. So the second graph is the graph of log T against log P. And the last graph is the ln P against 1 over T, and all three graphs will plot using the Excel. So for the calculation part, we want to obtain the heat of vaporization of water. First, we use the Cauchy-Clapeyron formula, and then we derive the formula until we get ln P equals to HV per R times 1 per T plus C. So you can see that Y equals to mx plus C. So y-axis will be the ln P, x-axis is 1 over T. So for the m will be the heat of vaporization over the gas constant, ideal gas constant. So to calculate the heat of vaporization will be the gradient of the graph times with the ideal gas constant, and from the experiment we obtain is 1.9138 joule per mole.
Okay, so please let me start our discussion part. From graph 1 displays an increasing line of absolute pressure against the average pressure. The average temperature started at 127 degree and 2.01312 5 bar, and then turned to 196 degree where the absolute pressure is 11.01325 bar. From graph 2, we can learn that the average temperature are also increasing with the log of pressure. The initial log average temperature is 2.603 degree and log pressure is 0.304. Then it turns to 2.671 degree and 1.042. This is the graph 1 and graph 2. Let's do a comparison. Compare the graph 1 with graph 2, we can learn that both of the graphs are an increasing line. However, the graph 1 has a sharper slope of its linear line than the graph 2's. It shows that the rate of change in graph 1 is greater than graph 2. In graph 1, we can see the relationship between pressure and temperature values of statute weight steam more clearly and directly. At the same time, graph 2 provides us a more specific and detailed view of the trend. Before we start the experiment, the air inside the boiler was expelled to avoid the air to accumulate inside it. This step was also done to obtain correct equilibrium measurements between steam and boiler water inside the boiler. In this experiment, the pressure and the temperature of water vapor is increasing. The volume of steam and heat of vaporization and also the entropy of steam are decreasing, while the absolute gravity of steam and supply of water as well as steam entropy of water are increasing. And for the industrial, water tube boilers are preferred and used in oil and gas industry due to high volume of steam requirements. And the relationship between pressure and temperature also can be used in food industry. For example, the industrial pressure cooker. It can provide more quicker cooking times, higher quality end products, and it is also easy to clean and for automatically operation, and it can saving our water and energy. Then the Marcet boiler consists of two values, which are safety value and blow-off value. The function of safety value is to automatically release substance from boiler when the temperature or pressure exceeds the preset limits. Meanwhile, for blow-off value, it functions as a pressure release system where it regulates the pressure inside the Marcet boiler. Besides that, it also prevents the compressor surge and reduces wear of the thermodynamic heater. Conclusion: from the experiment, it is found that the temperature of a saturated steam is directly proportional to the pressure in equilibrium with water. When compared to the theoretical slope, the experimental slope shows a small deviation between them because of certain error. The hint of vaporization for water calculated from the graph and from the derivation of formula is 1.9138 kgmol. Recommendation: the first one is never open the value when the boiler is heated, as pressurized steam can cause severe injury. And second one is the temperature reading should be taken at more pressure intervals to obtain greater accuracy. And the last one is check and rectify any leaks at the boiler in order to ensure an accurate reading is recorded throughout the experiment. Thank you very much. Have a nice day.